Hi everyone. Inverse logs. Quick video. All right, so I was doing logs myself from an inverse standpoint, and I said, gosh, there's got to be an easier way to remember this. And there kind of is. The major rule is something that will save you a lot of time and a lot of energy. 2 to the third power equals 8. That's the exponential part of this. That equals to, or is, log base 2, 8 equals 3, okay? That's how I'm able to convert one to the other. If you can remember to do that, you should be good to go in terms of finding the inverses from logs to exponential or vice versa. So let's do a couple of examples. Take a look at number 1. The question is y equals log base 3 x minus 10. First step is to flip the y and the x variable. So x will equal log base 3y minus 10. Now, because the y minus 10 is not in parentheses here, or there's nothing else on the side, I'm able to add 10 to both sides. Because remember the goal here. The goal of an inverse is to flip the variables at first and then solve for y. That's how we do inverses, okay? So I want to get y by itself, right? So the first step is to add 10 to both sides, which will leave me with x plus 10 equals log base 3y. Now, you might want to flip it around so it looks in terms of this. That's what I like to do. Because if I can see the log on the left-hand side of the equal sign, I'm very easily able to switch it to the exponential portion of this. Because it started as a log, so the inverse should be an exponential. Now, that's not always the case, but you won't see anything crazy like that on the test, okay? Now, so x plus 10 equals log base 3y, or log base 3y equals x plus 10. Well, since I know the rule, right, I know I have to get y by itself. So log base 3 is going away. But again, it says base 3, meaning 3 is the base of the exponential function, okay? And then it's going to be whatever is on this other side. So y is going to end up over here. So technically speaking, this should look like this. So 3 to the x power plus 10 equals y, or what I have circled here because I just like the way this, ew, that's a terrible arrow. Okay, I like the way it looks here, okay? So y equals 3 to the x plus 10 power. Now again, if you were to do a table of values here, remember inverses are just the opposite things switch. So quickly, x, y, 0, 1, 3, 7, 4, 9, right? Its inverse, or f of negative 1, would be 1, 0, 7, 3, and 9, 4. So if you were to do a table of values here, you should be able to match those things up correctly. All right? Let's take a look at number 2. Same process, going from a log to an exponential. So y log base 3, quantity x minus 10 plus 7. Again, flipping the y and the x, so x equals log base 3 y minus 10 in the quantity plus 7. First step is to subtract 7 on both sides, because again, we're trying to solve for y. So I'm going to have x minus 7 equals log base 3 y minus 10, or log base 3 y minus 10 equals x minus 7. Now, there's 2 ways you can do this. I particularly like this way because I see parentheses here. I get a little bit nervous when I see a quantity, so I leave it as such until the very end, which you can do, okay? So if I remember the rule, right, the major rule, all I know is that if I want to get y by itself here, now y is not technically by itself because the minus 10 is still there. So this is going to be y minus 10 equals the base of 3 and to whatever is on the other side of the equal sign, x minus 7. But now again, I'm trying to solve for y. I'm just going to simply add 10 to both sides, and I get y equals 3 to the x minus 7 power plus 10. Okay? Last problem. Again, and this one I'm going to go from an exponential to a log. This one's really easy. Y equals 2 to the x power plus 3. Flip the switch, right, on x flip the switch, that's funny. X equals 2 to the y power plus 3. I'm solving for y again. So I have to subtract 3 on both sides. X minus 3 equals 2 to the y power, or 2 to the y power equals x minus 3. And I know the rule, right? So I know that y equals, again, the base has to go into the little base portion here of log, and then whatever is on this side of the equal sign goes on the other side or adjacent side of the log base, all right? Now, last one really quick, sorry, so this is a lot longer than I thought it was gonna be. You don't need to know this for the test, but I wanna show you this anyway. This was number 6 on the practice that I gave you the other day. Hey, Titan, come here. Hold on. Everybody. Titan has awakened. Where? Where? Yummy. Yeah. All right, I'm going to keep this one because you're going to be bad. Okay. Ow, ow, you bit me. Okay, maybe I'm not. All right. Sorry. All right, the problem was there was a fraction here. So this is a rational function. This is really, really ugly, okay? So the first step is obviously for inverses, we're gonna flip the x and the y. So I have x equals 3 times 2 to the y power plus 1 over 2 to the y power. Next, now this is the part that a lot of you might have gotten messed up on. We have to separate this fraction into two different fractions because I'm not able to just simply get the 2 to the y divided by the 2 to the y and give me 1 just yet. I can't do that because there's a plus here. So I'm going to do two fractions, splitting these into two different sections, which I'm allowed to do, which is the way we need to solve this. Then I'm going to simplify. Now I'm able to use the exponent rules to get this out of here. 2 to the y divided by 2 to the y is 1. Now I have x equals 3 plus 1 over 2y. And now I'm able to simplify and get the log, because again, I'm solving for y. So I've got x minus 3, because I'm subtracting 3 on both sides, equals 1 over 2 to the y. I just switched this around. One thing that I forgot was 1 over 2 to the y power is the same thing as 1/2 to the y power. It's the same exact thing, okay? Which makes it a lot easier to take the log. It's just gonna have a base that's a fraction, all right? Hope you're having a great day. Test will be available a little later. Bye.